Saxon Algebra 1, lesson 104. You're in the right place for a really fun lesson. Ready? This is called Abstract Rational Equations. Lesson 103 was called rational equations. Okay, rational means fractions, equations means there's an equal sign, so we can actually solve for a letter. Abstract means there's more than one letter involved, and we can solve it for a letter, but we're not going to get a numeric answer. We're going to get an answer that has more letters in it. So that's why we call it abstract, because we're thinking more about ideas than we are about numbers, if that makes any sense. But here's the good news. The process is pretty much the same. It just looks different because there are letters. Okay, so this is the first problem. 1 over x plus b over m equals c. See what I mean about the letters? I mean, yeah, there's a number, but it's mostly letters, and we're never going to be able to reduce it all to a single number. Now, here's what's interesting about these. Notice this is already solved for C, and in and of itself, this gives us no instruction. We have no idea what to do with this until we look at the instructions, which I skipped because I wanted to make a point of them. John tells us not to solve, because solving doesn't mean anything in an abstract problem. He tells us which letter he wants us to find. What that means is solve for m. Get m by itself on one side of the equation. Okay, that we can do. There's the m right now. It's buried in the bottom of a fraction. That's fine. We can fix that. But unless John tells us what to find, we have no idea where to go. So you'll see that I always make a big deal of writing down the letter that I'm solving for and circling it, because that is my North Star. That's what leads me into the problem and reminds me of what the heck I'm doing. Now, we learned last time that when we have variables in the denominator, we have to set up restraints so that we don't let those things turn into numbers that would blow up the universe. So in this case, we know that x cannot equal 0 and m cannot equal 0. Those are our restraints. And what's interesting is John is now giving us this as part of the problem. He writes it like this. He puts the two letters together and says they can't equal 0. He's telling us we don't have to tell him like we did last time. So that's cool. We don't have to worry about it. The steps for solving are very similar to what we did last time. The first thing we do is we blow up the denominators. Okay, we did that last time. There was a step-by-step process. I'll review that in words, but if you want to see it written down again, the steps for blowing up denominators, go back to lesson 103. We wrote it all down there. Okay, so what we do to blow up a denominator is we find the LCM, least common multiple. We get it by multiplying together the different pieces. So this one's going to be xm. We multiply every term by the least common multiple, and I write them up here at an angle. It's my angle parking. And then we cancel. There's the m that's left and the x that's left. And this time both of them are left, right? So I crossed off what canceled, and then I circled what was left. Now I'm going to go through and multiply. 1 times m is m. B times x is bx. I keep it alphabetical. And then this one, I'm going to keep it alphabetical. I didn't make that alphabetical. I could have, but I like this. Okay, beautiful. Now we blew up our denominators. 2, the next step is move all terms with desired letter to one side. Okay, what the heck does that mean? I hate how words cannot describe math. Well, they can, but it takes too many. We're supposed to be finding m. Here's an m, and here's an m. We want to move them to one side of the equation. It doesn't matter if we go left or right, but we want to get all of the terms that have that cute letter that we're after, we want to get them to one side. So looking at this, I see, okay, there's my equal side. This just has one term. So I'm going to move this m over here, and that will leave this weirdo guy that we don't care about. That'll leave him by himself. So I'm going to subtract m from both sides. I get bx equals cmx minus m. Okay? So that's step 2. 3, I'm going to factor out my desired letter. In this case, the desired letter is the m. So I'm going to write bx, I'm leaving that side alone, equals m times the quantity, and now what's left when I factor the m out? Cx minus 1. Remember that when we factor the whole term, we're left with a 1, not a 0. We don't drop it entirely. It's a minus 1, right? And the way you can check that is redistribute. If we multiply this, we'd get cmx here, check, and then we'd get 1 times m, we'd get m. There it is right there. So if you want to check to see if you factored correctly, try redistributing and make sure it works. Okay, now we're almost done. 4, we just divide away the part we don't want. So we're going to divide, we want m by itself, so we're just going to divide cx minus 1, cx minus 1. Those cancel, so we get m, I'm flipping the sides now, equals bx over cx minus 1. And that's the right answer. And also we need to say here that cx cannot be equal to 1, right? I could set this up as equals 0, add 1 to both sides, but I can also just look at it and go, okay, if cx was equal to 1, that's when disaster would strike. So this is also part of my solution. John set up the restraints on the original equation, and then I have to set them up, and you have to set them up for the answer. This is the answer. Okay? I'm just checking my brain. There it is. xb, I said bx over cx minus 1. Yay. This is right, and this is right. Okay? So we get rid of the denominators. That was lesson 103. Then we follow these steps to get the desired letter by itself. Let's do another one. How many are there? There's only 3 in this lesson. Ready? Example 104.2. This is cute. A over B plus C over D equals X. And John tells us that B and D cannot be equal to 0. Okay, I believe that. And this is a good reminder. John sets it up for the beginning. We have to fix it in the end. What are we supposed to be doing in this? I don't know. We have to look at the book and see what John says. He says find B. So I write down the letter I'm looking for and I circle it hard to remind myself of what I'm doing. Steps. Number 1, blow up the denominators. Find the least common multiple. It's B times D. Multiply everything, all the terms, right? This one, and this one, times that. That doesn't look very angled. Cancel. And this, before we had the zeros here, right? Remember in lesson 103, and we kept wiping that out. This time, no, they stay. So now we have AD plus BC equals BDX. Sounds like a skater clothing brand, BDX. Okay, so far so good. Now we look for the terms that have the letter we want and we collect them on one side of the equation. B is what we're looking for. There's a B and there's a B. Okay, there's a non-B. So let's swim the BC over to that side. That cancels. We get AD equals BDX minus BC. We could write these in either order. We could write minus BC plus BDX. I like to write it like this because I like the minus sign to be in between the terms. It helps me pay attention to it better. It's easier to lose it to me when it's just on the front. So I always write mine this way. Okay, now we factor out the letter we want, which is B, and that leaves us with dx minus c. We can distribute to make sure we did it right. That looks good. And then we divide away this chunk we don't care about. Dx minus c. And then here's a little, those cancel. Here's a little trick that I do so I don't have, these are only gonna get bigger and messier. What I do is just, I rewrite equals B over here and then use that as my answer so I don't have to write it one more time because it's easy to make little mistakes. And, sorry, I was looking at the answer to the wrong problem because I was like, wait, how could I get that wrong? Okay, and then we also have to see that dx minus c cannot equal 0. So those are the two parts of our answer, yay. Okay. Let's try another. This is the last, no, there's 2 more. There's 4 total. Ready? This time we're supposed to be finding x. Lawnmower's going hard in the neighborhood today. It's sunny. Okay, b and x cannot be equal to 0. John tells us that. Here's our problem. We're solving for x, okay? The first step, the blowing up of the denominators, it really doesn't matter what our letter is. So our LCM is going to equal b times x. Get my angles going. Cancel out what cancels. Circle what's left. Notice that if we have no denominator, nothing cancels and we keep it all. The x is gone, we just keep the b. Okay, ax minus bcx equals, that's a d, b, d. Okay, so far so good. Now we look for our desired letter and we collect those all on one side of the equal sign. Oh, look, it's already perfectly set up. Here are the 2 x's and BD is over there. Cool. So now all we need to do is factor out the x, a minus bc equals bd. That part doesn't change. And now we divide away the part that we don't like, because we want the x by itself. That's what I'm really trying to say. The reason we don't like this is because it's clinging to that x, and you know what? Go home. So we divide this side by the same thing, and there's our answer. So I'm not gonna write it all over again. I'm just gonna rewrite the x, because x equals, this all cancels. Here's the x by itself. I just move it to this side so I can show the answer, like so. BD over A minus BC, beautiful. And then this time, A minus BC cannot be equal to 0. Beautiful. Okay, we don't have to do any algebra to this because it's all just letters anyway. So it wouldn't really make it any better if we said, if we did anything algebraically to that. This is fine. Okay, yay. One more. Example 104.4, find x. Yes, Grace, I know. She's groaning in her sleep. Now I'm copying this the way John writes it in the book. He has fraction and then he has floaty dude. You know how I feel about floaty dudes. I want, if we're gonna do fractions, let's all do fractions. I haven't been doing that up till now, but I think that it bears a mention. It just helps keep things straight. I don't like having letters or numbers sort of floating in the middle. It's better to just see everybody as a fraction. Okay, and John tells us that x and n cannot be equal to 0. I like that he does that because it reminds me, oh yeah, I need to do that myself at the end. So that's a good reminder. Okay, least common multiple. We're blowing up the denominators. It's just x times n. I'm gonna write it alphabetically because that's how I roll. Every term gets multiplied by the same thing. That's how we keep our equation in balance. Cancel, This all stays the same because the 1 doesn't have anything to cancel. There we just have the x, and then that's everything. Okay, now we go back and simplify our multiplication. an minus nxy plus mx equals knx. It's like connects. I always try to make words out of the clumps of letters. That is a strange thing. Okay, so now we've got a beautiful no denominator equation. Praise the Lord. Now we are looking to collect up all of the x's. Where are they? Here's one, here's one, here's one. Okay, there's the equal sign. I vote we move them all this way. You can do it either way, by the way. We could move him over here and this guy over there. It will all work out the very same. It doesn't matter. So that's just your option. I just try to do it in as few moves as possible, or as simple as moves as possible. So I'm going to add nxy, and I'm going to subtract mx. So that goes, and I'll get an equals, and then all of this, knx plus nxy minus mx. Okay, all the x's are on one side. Now I'm going to factor them out. Okay, so if I factor an x out of this, I get kn plus ny minus m. Double check that by making sure if I distribute this, do I get all the first terms back? Yes, I do. And now we're going to divide by this monster. Now you're getting a better idea of why I don't like to keep writing it. Kn plus ny minus m. Kn plus ny minus m. This all cancels. This is my answer, and there's the equals x. I just rewrite it over here. This looks a little wonky because the an's way down there, but it's okay. This is my answer. And I also have to say that kn plus ny minus m cannot equal 0. Put my restraint on there. And I'm just double checking. John's got his letters in slightly different order. He has NA, well, AN and NA are the same thing, over NK plus NY minus M. So these two letters are reversed. If the letters in the same term are just in a different order, that's okay, because in multiplication, order doesn't matter. So this is all absolutely fine. Okay, that is lesson 104. You know now how to work abstract rational equations. Oh, you are a much more richly diversified and textured individual because of this new knowledge. I'm proud of you. Lesson 104. Goodbye.